In this example, we have a cannon firing a cannonball. The mass of the cannon is 4.5 times 10 to the 5th kilograms. The mass of the cannonball is 1.2 times 10 to the 4th grams. The cannon fires the cannonball with a velocity of 145 meters per second. And the question is, what happens to the cannon after it fires? Well, the law of momentum conservation says that the total momentum before has to equal the total momentum after. Well, what's the total momentum? We have two things here. We have a cannon and a cannonball. So the total momentum will be the sum of the momentum of the cannon and the momentum of the cannonball. If I use c to denote the cannon, then the momentum of the cannon is mc times vc. If I use cb to denote the cannonball, then the momentum of the cannonball is mcb times vcb. That's the total momentum. Well, the total momentum before has to equal the total momentum after, so that equals mcvc plus mcbvcb after. Before the cannon fires, it's not moving, so m cannon times v cannon is simply 0, because v cannon is 0. In the same way, m cannonball times v cannonball is also 0 before the cannon fires, because the cannonball is not moving either. So that takes care of the total momentum before the cannon is fired. What about afterwards? Well, the mass of the cannon is 4.5 times 10 to the 5th kilograms. We don't know what's going on with the cannon, so we don't know what its velocity is. We'll just leave that as v cannon. The mass of the cannonball is 12 kilograms. 1.2 times 10 to the 4th grams needs to be converted to kilograms to make the units work out. I assume you know how to do that. And its v is 145 meters per second. When we deal with all the numbers we can deal with, this equation reduces to 0 equals 4.5 times 10 to the 5th kilograms times the velocity of the cannon plus 1.7 times 10 to the 3rd kilogram meters per second. The only thing we don't know in this equation is the velocity of the cannon, so we can solve for it. We have to subtract 1.7 times 10 to the 3 kilogram meters per second from both sides of the equation and divide by 4.5 times 10 to the 5th kilograms. So the velocity of the cannon is negative 1.7 times 10 to the 3 kilogram meters per second divided by 4.5 times 10 to the 5th kilograms. Kilograms cancel, and we find that the velocity of the cannon is negative 0.0038 meters per second. What does the negative mean? Well, remember, in physics, negatives typically denote direction. The velocity of the cannonball is given as positive. This tells us that the cannon moves the opposite way as the cannonball, because the velocity of the cannon is opposite the velocity of the cannonball. So the cannon travels with a speed of 0.0038 meters per second in the opposite direction as compared to the cannonball. In physics, we call this recoil velocity. A cannon, a rifle, a pistol, anything that's shooting something will travel in the opposite direction as the projectile it shoots in order to conserve momentum. If you've ever watched video of a cannon firing, you'll see that the cannon actually moves backwards when it fires the cannonball. If you've ever fired a rifle, you've probably experienced the kick that a rifle gives when it fires its bullet. Once again, that's recoil velocity that's necessary in order to conserve momentum.